Thank you very much. Our main theme for the conference is Shaping a Better Future Through Sustainable Technology. Sustainable technology itself can be broadly defined as technology that has social and environmental impact. By having these impacts, technology can contribute to achieve the Sustainable Development Goals already set by the United Nations, ranging from the first goal in fighting the poverty to the 17 goals in building partnership to achieve the goals. Ladies and gentlemen, to start the event, I would like to invite the Director of Politeknik Negeri Batam, Dr. Uuf Brajawidakda, to deliver the opening remarks. Please welcome. Difficulties. And now we will proceed to our next agenda. Uh,
Distinguished participants, ladies and gentlemen, it is my great pleasure to welcome you to the third International Conference on Applied Engineering, or we call it ICAE 2020. This year, ICAE is held in conjunction with the second International Conference on Applied Economics and Social Sciences, or we call it ICAESS 2020. We also have the 8th Applied Business and Engineering Conference, or ABEC 2020, which is held together in this event. We have prepared all things required to welcome you here in Batam until we all experience these unprecedented situations with the global COVID-19 pandemic. But someone said the show must go on. I do appreciate the organizing committee's effort to make this event held virtually. Once this pandemic is over, I do really hope that we can welcome you here in person in the near future. ICAE 2020 has selected 40 papers out of 62 submitted papers with acceptance rates of 64%. These papers are addressing issues ranging in information systems, data visualizations, robotics, modeling, and other related fields. For ICAESS 2020, we received 240 papers and accepted 68 papers to be presented today, with acceptance rates of 28%. We also have 65 papers to be presented in ABEC 2020. We express our gratitude to all who helped make ICAE 2020, ICAESS 2020, and ABEC 2020 a success. It requires a significant efforts of many people to make this conference possible. We thank the organizing committee's members, along with the numerous reviewers who reviewed and discussed the submitted manuscripts. These reviewers serve to bring a broad set of perspective to the research area. We especially thanks to the authors who took the time and carefully write up the results of their research and submit papers to our conferences. The quality of these papers is a tribute to the authors and also to the reviewers who have guided any necessary improvement. We thank our partners, including Batam Authority, ICAE, International Islamic University Malaysia, Politeknik Negeri Bengkalis, Politeknik Caltech Riau, Politeknik Manufaktur Negeri Bangka Belitung, Politeknik Negeri Medan, Politeknik Negeri Padang, and Politeknik Pertanian Negeri Payakumbuh. Last but not least, we are greatly indebted to our four keynote speakers, Ms. Diana Sutanto of Nanyang Polytechnic, Singapore, Dr. Ronnie Sutarto of Canadian Light Source, Dr. Agnes Lesage of Infineon Asia Pacific, and Dr. Rozaimi C. Hasan of University of Technology Malaysia for accepting our invitation to address this conference. We hope you enjoying this conference. Thank you.
Thank you, Mr. Ulf Brajavidakta, for the remarks. Our distinguished speakers and all the participants, as already instructed in the chat feature, we are inviting you all to turn on your camera because we are having a photo session. I will count to 3 as the team will take the frame. There are several pages of participant pictures that need to be taken, so please bear with us until the last one. One, two, and three. Next page. One, two, three. Another one. One, two, three. One more. One, two, three. And the next one. One, two, and three. Another one. One, two, three.
Dia berusaha kreatif seperti itu.
The last one. One, two. Bear with us for the photo session, and now we will proceed to our next agenda. Technology has been a crucial part in the history of mankind, as well as in determining our future. Specifically, in the recent decades, technology is key for competitiveness and economic superiority. However, technology itself is a double-edged sword. Besides the economic impact, technology also contributes a lot to the pollution, health issue, social issue, and other negative impacts to our social life and environment. To achieve this, technology should contribute more to social and environment. Therefore, we can have a better future through sustainable technology. Ladies and gentlemen, I would like to inform us that due to the urgent meeting with the Taiwan government, Professor Xiao Yuan Huan couldn't join us here today. We hope that we will be able to work together in the near future. And now we will proceed to our first keynote speaker, Miss Diana Sutanto.
Hi, good morning, everyone. Hi, morning, good morning. Selamat pagi. Terima kasih telah mengundang saya untuk konferensi ini ya. But it's because it's international conference, I will switch to English. But if at any point of time you need to ask me any question in bahasa, I'm fine. But most likely I will try to answer in English as well. I've not been back for a very long time. Yeah, so thank you very much. Can I just share
Yes, please. You
sharing
can open your file and then you can
of
start.
my slides?
Yep.
Give me a second. Okay, share my slide. Will you be able to see my slides now? Okay. Right. So this morning I would just want to share about technology transfer. Actually, it's an honor when I see I looking at the agenda, I look at the rest of the speakers. Actually, I felt like whatever I'm going to share later is just a reiteration of what all the polytechnics in Indonesia have been doing. I'm very proud of it. So today, my sharing will be on sustaining capabilities and economic development through innovations. What is all technology transfer all about? Because today conference is all about sustaining technologies, right? Technologies comes and go, but our capabilities for all our lecturers and professors are continuation. There's a continuations. That's why there's a sustaining in our capabilities, and it will help in our economic development. Right. So this is what my agenda is. Just a few coverage. I hope I won't take up all the 30 minutes so that the rest of the speakers have more time. Right. Of course, the very first one is talking about the change drivers and the need for innovations. And then we will go into the technology transfer, what and why. And its continuation with how to manage your IP and commercialization. During the introduction today, I'm very surprised, and I'm very honored to see that actually there are some patent filing from the polytechnics and also the design registrations, and there's already clear pictures of how to protect your IP and how to manage your IP. So I thought that it's just going to be a reiterations of what good works you all have been doing, and so I'll later on with the Q&A. Right. So we all know there are drive for innovations because the business competition have increased over the time, and the product life cycle is getting shorter and shorter. Like your phone, every year you change your new phones. Everyone wants a new products, and the consumers are getting the expectation is getting higher and higher each day. So new technologies are expected to replace the old one very, very fast. And the advancement itself, uh, the technology advancement itself is also change a lot of things. And we are competing in a very, very competitive world, right? So I'm very happy to say that looking at what Indonesia is doing, the development, the country's development, and things like that, is all moving into a very very innovations driven kind of solutions. drive the innovation in Singapore. There are a lot of fundings given to bring high-tech industries into the nations to increase the value and to increase the employment at the end of the day. And I'm quite sure we can see also Indonesia has changed along the way. And from what I have seen from the agenda today, the sharing of the rest of the speakers, I'm quite sure that we are very much innovation driven as well. We, because I used to be Indonesian. So okay, so for a good relationship, for a good innovations to come in, it has to be come from three parties. It always have to come from government agencies, from the economic perspective, what kind of area that they want to develop, and also the industry. They always bring in from what kind of business development and services that they want to bring. From the education institutes is where all the knowledge and capabilities are looking at, and in this picture itself, there's a sweet spot that we all want, and it will be the best outcome for technology transfer and innovations. Right. So moving forward is that there is a very research and tech transfer strategic development. There's a lot of research and development done all at different countries, and I believe in Indonesia as well. Looking at the papers that Pak Uuf mentioned, there are so many papers that come out from all the participants, right? So beside the R&Ds, it builds your capabilities of the professors itself and the lecturer. But of course, with the capability developed, there's also the portion about the IP management. How do you manage the knowledge? Uh, knowledge industry at the end. So from the industry itself, they are always looking at their problem statement. They are looking for solutions. They want to commercialize. They want to make money. But from the universities and the research institutions, they always so they also always wanted to have a knowledge creation. They want to enhance their capabilities. That is what all the professors wanted to do. And from the national initiative itself, the government wants to drive in certain areas. What it could be information ICT. It could be in some technologies like nanotechnologies. It depends on government to government. But looking at how things are developed, I'm quite sure Indonesia are looking at ICT, or the worldwide is looking at ICT as the one of the solutions right now, like AI, Industry 4.0, Industry 5.0. So there is no conflict in between these three partners that are looking for areas to work on. Each one have their own focus, but there is a coherency and there is a synergy to work together to come up to have a sustainable economy development and knowledge creation. Right. So okay. So the difference between the industry and the institutions is from the institution perspective, the professors are looking at applied R&D, where we come up with some prototypes, proof of concept, based on the knowledge that you have developed, the knowledge that you have gained during that period of time. But usually from institutional perspective is once I do the proof of concept and I write my paper or I protect the ideas, that's the end of my job. But the industry wanted something to make monies, that they want to do the market adoption, and they look at prototype and proof of concept. There's still a large gap up to a commercialization level. So this is where we call it the valley of death, where a lot of good ideas, a lot of good technologies, the prototype, the proof of concept that you have developed died during this period of time because the industry wanted a more mature technologies, but the institutional are unable to deliver to that commercialization stage. So in that sense, what do we do? Because when you have too many valley of death, it doesn't help the economy at all. So in actual fact, we need a change of mindset. We need to do a co-creation and collaborate, or they could engage another companies to come in to do the productizations and the industry projects as well. So we need to continue to do the collaborations, and that is where there is a technology transfer in between at the center stage, where the institution will come up with all the procedures up to the proof, not just proof of concept, but it will move slowly to the proof of value. What it means by proof of value is that your concepts, the prototype that you created must be it's become very expensive. So we also now looking at whether there are ready processes that can help to productize all our technologies as well. So that there's a relevance see to continue to have a very close collaboration with the companies and industry. Right. So in order to have a sustainable mindset, sustainable technologies, and sustainable economic development, we need to keep track of the trends and changing landscape for both the professors and of course the industry, right? Especially for the small and medium enterprise. There are many small and medium enterprise that are unable to keep up with the trends because they are more into the same old technologies that they are used to. But it needs two hands to clap. So both the lecturers, both the institutions and the companies have to look at the trends and the changing landscape of the industry. And of course, there's a demonstrate innovation beyond the technologies is where we talk about how we bring the innovations all the way to the commercialization and not just move and start at the proof of concept side. Yeah, we always to have developed with customers' need in mind, and to use this knowledge and capabilities to enhance the teaching and learning at the end of the day, because at the end all the professors are still doing teaching, right? And what we want is to pass the knowledge back to the students so that they can improve their skills as well. So I just give an example. I'm actually looking at the introduction this morning. Y'all are very impressive. So this is just a very small part of our robotics and automation centers that we use in Nanyang Poly. That we built over the time because of our background previously from EDB. We are very close with industry, so a lot of industry will come with their needs and tell us their scopes, and we use all our capabilities to produce it back. So I'm quite sure Batam Poly and all the poly in Indonesia are very working closely with the industry as well. So because I saw all the industry names in the agenda as well just now. right? So just to give an overview of the changing landscape, it used to be when a professor worked on challenge or looking at the new areas that they want to develop. What they do is that they will just write a proposal to get a funding, and then they like, we have to do our landscape analysis. So when we do submission of proposal, we already try to understand uh, we tried to understand the landscape of the technologies and also the applications, and we actually identify the partners to work with and try to understand their needs as well. And from there itself, there we submit a proposal and translate the development. So it is by design right now. Is less of by some database that you can look for uh, top technologies, but we actually use Frost and Sullivan, where they will give us like the top 60 technologies in 2020, and the schools will look at which area they wanted to focus on. The lecturers will then say that, okay, if we want to have to build the capabilities in predictive analytics, what should we do, what kind of capabilities we need to build, what kind of project we can start to work with, and looking at our current capabilities, is there a gap, and then how we can sustain and learn it and try to apply it. And I'm quite sure I saw a lot of information map where the government will map and tell us which industries that they want to build over the time, in the next 5 periods of time. Like if they want to do precision engineering, will be the one top important area that they want to continue to develop. And then we will think of, okay, from our capabilities, how we can work together in this area. Is it robotics, is it data analytics, can IoT, internet of things can be applied in this area of aerospace, of electronics, even like for this, like for the manufacturing, we didn't look at blockchain, but there are some lecturers from our side now looking at blockchain to be used for manufacturing as well. So you can use your innovations to apply into that area and see whether there are industry partners that are willing to give you the chance to work with them, if they think that it is a very interesting area to work with, and it has some commercialization value at the end of the day. Of course, commercialization is not the only way of doing things, but there are times that is also for social responsibilities, and also for like currently like COVID-19, a lot of projects is trying to solve COVID-19 problems as well. So does it make economic sense? Well, some of it, if you came up with vaccines, of course, there's a lot of economic value, but there are things that is really to educate the people as well as social responsibilities. So not all the things are about money and value lah, but it still bring value in a way, right? So this is how technology transfer is done in Nanyang Poly, where we look at from the ideations all the way to commercializations. We try to protect the ideas. So if our lecturers come with some ideas of the previous work they have done, we will see whether it can be protected through patents, copyrights, and even trade secrets. So we have to decide what are the best way of protections, and then we try to work with the industry partners to translate these ideas into productizations, or even a commercializations. So even for the commercialization itself, at times we also help with the business development of the company's ideas, because for SMEs, sometimes it is very, very difficult to develop the business idea, but as a tech transfer department, we have to seed the idea, at least seed the idea. What are the possibilities? What are the applications that possible for them to use? So it can be very interesting, like for a project that we have done for polymers. Then now it can be used for some metal industry as well. So it is the innovation is really based on your creativity on how to apply it at the end as well. Right. So this is just an example of what we do. This is a health track software we do with National Healthcare Group. So we have IP, intellectual properties in a configurable multilingual advisory system. So what it does is that it can change the language very easily. So for so the doctors actually come to us and mention to us that they have an issues, they want to do a survey for the people that come in and seek to seek medical advice, but in Singapore there are so many languages that people use. Some of it is in English, some Malay, some Indian, and Chinese. So it was done quite a while ago. So this is so what they do is that the patients can and come in and do and they will within that 5 minutes, based on your preference of language, they will roughly know your profile of your health, that whether you are in a high risk or low risk, uh, that for diabetes and things like that. So they will then send you a referral letter to the physicians to look at possible conditions. So the doctors actually come up with some um, some not algorithm, but they knows from their physicians method that how to do triangulations to find out that you have a very specific conditions, right, from a few questions that you ask. So from there we use the algorithm, and then we found out that yeah, it helps. And right now we are charging for every patients that come in, we charge $10 Sing dollars for them to do this. So actually the patients might not be paying full $10. Government is subsidizing, but NYP is sharing some of the profit, and the I think quite a bit it goes to the polyclinics profits as well. Right. So at the end of the day, to sustain an innovation ecosystem, it is not just about what we think, what idea that we good idea we come up with. It needs the whole ecosystem to sustain the innovation, right? We need the government agencies to tell us that what kind of fundings are available for us to tap on, whether they have insights on what areas that they want to focus on. In Singapore, this is done by EDB, by Enterprise Singapore, and also a few agencies like building and construction agencies. I mean, each agency have their own areas that they are looking at, so we can tap on their insights, and then we also try to find out what the funding that we can tap on, because there are a lot of R&D funding that we can tap on from there. From the industry is where we looking at companies' problem and issues, and we try to sense also whether some of our ideas does it make sense, and or whether it doesn't make sense. So the specialist centers and the labs are usually found, of course, in the institution itself, in the polytechnics itself. And most of the time, we also work with universities and research institutions, because at the end we are doing applied R&D. What at times we need is to have a bit of a higher level of technologies that we need to tap on. So we actually work with universities for some of the technologies that they have. Of course, you can't leave the staff as students, because staff is where all the knowledge, the expertise and skill sets are. So they are the so-called the backbone of the whole innovation ecosystem. So it is, at the end, everyone is important in the whole ecosystem. Okay, so I guess I'm at the end of my presentations. Yeah, so I can take Q&A.
Delightful presentation. There are a lot of messages from the material delivered by Ms. Diana. If I might point out the highlight, that is maybe the importance of sustaining capabilities and economic development through innovation, which is the challenge is
Right.
lead good industry institution,
I don't see any
government, and relationship to develop the research and technology transfers. But we will save for the Q&A session later after all of the speakers already delivered the material. And for all the participants, if you have any question, please write down your question in chat or by activate the raise hand button. And now we will proceed to our next speaker, the second one. Please allow me to invite Mr. Ronnie Sutarto of Canadian Light Source, who will deliver synchrotron science for sustainable energy materials.
Okay, hi, good morning. Okay, hi, good morning. I will start to share my screen.
Yes, please.
So you can see my screen now? I think I need to, hold on. It says the bandwidth is really heavy here. Maybe from time to time I will switch off the camera. Actually. Okay, anyway. So good morning, everybody. Probably if there is participant in North American, should be good evening now. Let me start by thanking the organizer in inviting me to give a talk. It is my great pleasure to share some of my experience with synchrotron-based research. In the next slide, I will introduce you what synchrotron is and how it can act as a solution provider for the fundamental and real world problems. Is my voice is clear enough? Or do I need to speak louder? Oh, okay, yeah, thank you. The synchrotron I'm working at as a scientist is called Nearest Canadian Light Source. So let's see if I can change to the pointer, to laser pointer, yes. So Canadian Light Source, it is located in the city of Saskatoon in the province of Saskatchewan, Canada. I'm working at the CLS since 2011. So let us first look at the world map. Here is Indonesia, as you know. Batam is located somewhere there. And where is Saskatoon? Saskatoon is here. So Saskatoon is situated in the province of Saskatchewan, Saskatchewan province. It is in the central part of Canada between Alberta and Manitoba province. The Saskatchewan area is 600 square kilometer. It is about similar to Kalimantan Island area. The population in the Saskatchewan is about 1.1 million people. So if we compare it to Kalimantan population density, it is about 15 times less. So not so many people there. Its natural product for economy are agriculture such as wheat, and also mining such as potash, oil, uranium, and so on. So now let's compare between city of Saskatoon and Batam itself. The inhabitants in Saskatoon are about 275,000 people, where in Batam, I think, if I search on Wikipedia, it's about 1.3 million. So actually the population in Batam itself is already exceeding the population in the whole province. And then the density itself, as you can see, is about 60% less in Saskatoon compared to the one in Batam. So how about the temperature? The temperature is quite, looking at the weather, here is the typical temperature in Saskatoon. During the winter season, the average high and low temperature is about -12 and -22, let's say 25 degrees Celsius. While during summer season, the average high and low is 25 and 10 degrees Celsius. These are only average, of course, average temperature. So, but the highest and lowest temperature record are certainly more than that. This is an example how it looks like. Actually, this is my first winter in Saskatoon in the early 2012. So it was -37 degrees Celsius until -40 degrees Celsius. It's normal for the local Saskatoon people in facing this harsh, extreme cold condition, but it was a kind of new experience for myself. So enough with the introductory note. Let's start with showcase the capability of synchrotron to capture internal structure of a rechargeable lithium-ion battery cell with a non-destructive imaging tank. And the second one is on the observation of a new electronic ordering phenomena on the copper-based superconductor. So the second one is a bit more fundamental science. Okay, one slide to advertise about synchrotron around the world. There are not so many actually, only 40 to 50 synchrotron around the world. And the Canadian Light Source is the only one on the Canadian soil. I do not remember exactly, but as a comparison, there are maybe about 5 synchrotron or more in the USA. There are 4 in Germany, 2 in Japan, and so on and so forth. Actually, the one that are closest to Indonesia, you can easily find one in Singapore. Maybe Diana knows where is it, and then one in Thailand, and as well as one in Australia. So what is synchrotron actually? It is basically a machine that generates an intense beam of light, which is brighter than sunlight. This synchrotron light is then used by scientists to conduct basic and applied research in many diverse areas that you can think of, ranging from physics to biology to agriculture and even to technology itself, which are not possible using conventional equipment. One can illustrate the synchrotron as a giant microscope that allows us to see a finer detail of your sample. We will look into this more detail in the following slide. Here are what you see here is the picture of internal view of our building behind this concrete wall. So here is a concrete wall. Behind that, the synchrotron light is being generated. So what type of intense light that is produced at the CLS? Normally, what we have in mind as a light only refers to a visible light, right? However, visible light is only a small portion of the electromagnetic spectrum that is ranging from radio wave to gamma rays. In daily life, we can easily find or encounter the use of these lights separately. Let's say for the visible light is used for the optical microscope. The X-ray itself, you can see it in the airport scanner in the hospital as well to see the content internal of our suitcase, of our body, and so on and so forth. But the light that is produced at CLS is a wide range from the infrared to ultraviolet. This to of course visible light will be included there, and then to soft X-ray and hard X-ray region. This corresponds to energy of 1.6 milli electron volt up to 140 kilo electron volt, or in other words, in the scale itself, in the length scale, it corresponds to, let's say, about 1 millimeter to 10 minus 2 angstrom actually in this hard X-ray region. So as I mentioned before, by using the quote-unquote super microscope with this breadth of light, you can see and study the internal structure of cell, virus, molecule, DNA, as well as study about atoms and electrons. So now the question is, why is synchrotron light so special? Because here are the list of its advantages. It's quite a long list, but I will pick up the first one. High brilliance or high flux. The light that synchrotron generates is million times brighter than the medical X-ray and even sunlight, as you can see here. So it's let's say for the sunlight and medical X-ray is maximized about 10 minus 8, 10 minus 9 brightness. However, the synchrotron light is much higher here. So especially in the range of ultraviolet and X-ray, it gives us maybe 2 to 6 order of magnitude higher. So this has implication that the experiment that can be completed faster, and the image or spectra generated is finer. It's also produce a continuous and wide range spectrum where we can select its energy from infrared, UV light, and also X-ray. As a general rule, hard X-ray with soft wavelength are most useful for the probing atomic structure and elemental identification. Again, as a general rule, for soft X-ray with longer wavelength and ultraviolet are good choice for study chemical composition, chemical reaction, and electronic structure. For infrared itself, with its very long wavelength, it's ideally suited for to studying atomic vibration in molecule and solid. Other advantages are also listed here, listed below, such as tunability of its light polarization from linear electric field to circular electric field, excellent collimation, where the angular divergence of the beam is small, and so on and so forth. But one thing that is important also is we can conduct multiple scattering multiple experiments simultaneously in many experimental laboratory or on station, which is impossible to be realized in the conventional equipment. So let's now hear a short presentation of how synchrotron works. Actually, I hope the linking works. Let's see. Okay. So just to recapitulate what we just shared, synchrotron light source typically begin with an electron gun containing a material which is tungsten oxide disk at the CLS, to which an electrical and thermal current is applied. This results in an ejection of electron from here, of free electron from a tungsten oxide disk, and the electron begin their journey by being accelerated in this linear section, the so-called linear accelerator. So the energy will be boosted up to 250 mega electron volt, but then they enter a circular shape booster ring, where they are accelerated to relativistic speed, and their energy is ramped up to 2.9 giga electron volt. Finally, they will enter the outer bigger ring, which we call it storage ring, where the electron will circulate for hours and hours. Synchrotron light is then produced when the electron changing the direction. So first are electron here, and then when the electron changing the direction, it will produce some light, yes, synchrotron light. It happens when they are manipulated by bending magnet or as they pass through its device. The synchrotron light then branch off the storage ring, go to the experimental laboratories or known as experimental phase beamline, where its energy is refined by device such as monochromator and mirrors, which eventually shine on the sample at the end of the laboratory called the experimental end station, enabling researchers to conduct the experiment. So who uses the synchrotron and which technique that are offered at the experimental end station? As a national research facility, the CLS has hosted more than 3,000 researchers from all over the world, which have a very wide range of expertise from physics, chemistry, biology, medical, medicine, agriculture, and so on and so forth, engineering, science as well, even art and archaeology, and goes on. The list are not exhausted here. Regarding the technique that are offered at the 22 operating beamline or end station are also long lists, but we can broadly break down into three categories. Namely, first, spectroscopy, which cover, let's say, X-ray absorption, X-ray emission, X-ray photo emission, and so on and so forth. The second one will be about diffraction, reflectivity, and scattering. And the next one is about microscopy or imaging, which include computed tomography scan. So at the CLS, we focus on four main sectors, namely agriculture, health, advanced material, and environment. So in a agriculture area, the project that we are dealing with is on increasing crop productivity, agri-product development, and early detection of crop infection. This is one example of it. In the early stage of infection, many crop diseases can be difficult to diagnose and much less quantify and assess. Synchrotron-based X-ray imaging allow us to image tissue inside the plant itself, and it's often sensitive enough to differentiate between infected and healthy tissue. The top left here is about the width spike. So as you can see, externally, based on the photograph here, there are no difference between the healthy and infected width spike. but X-ray imaging can reveal internal structure difference between those of two. But I'm not expert in this field. From this study, we can quest to develop treatment and infection-resistant genotypes for crop in the future. For the health sector, it is ranging from, let's say, drug development to protein crystallography, to biomedical imaging on medical implant, research animal, dental structure, and so on. Here is one example study related to breast cancer. Breast cancer is the second leading cause of cancer death in Canadian women. A team from University of Saskatchewan became the first group to localize and identify level of sulfur, calcium, and potassium in the cancer-associated fibroblasts using X-ray fluorescent imaging with elemental mapping technique. The normal fibroblast is on the bottom panel here, and the cancer-stimulated fibroblast is on top. As you can see, there are different, right? And here is more intense. So from here, you can see that the increased level of this element actually might affect cellular activities connected to the breast cancer progression. In order to prevent malignant cancer growth, early diagnosis and treatment is important. This new result shed light on chemical changes within fibroblasts that may be used as a marker to detect the early stage cancer and can help to reduce the number of women who die from breast cancer. Next one is the next sector on the environmental. So the investigation using synchrotron light span from mining science, oil and gas tailing, soil science, and water treatment. Here I only want to highlight about study from the University of Regina about the role of functional iron titanium nanocomposite at porous ceramic filter dish in filtering out bacteria and improve clean green drinking water. For the advanced material sector, it is ranging from energy storage to composite material to catalyst and so forth. But in this occasion, I will use opportunity to showcase two topics on the sustainable energy material. The first one is about rechargeable lithium-ion battery. Since its first introduction to the market by Sony almost 30 years ago, lithium-ion has become one of the most popular rechargeable battery technologies, providing energy for today's consumer application. Its high energy density, no memory loss effect, show loss of charge in standby mode, and also this lightweight makes lithium-ion battery to be used for energy storage for many applications, especially to provide alternative solution for the heavy lead-acid battery. Here are a few examples of the lithium-ion battery cell format, ranging from pouch cell, prismatic cell, where in principle is a flat cell type, right? Has similar internal basic structure, but they only differ in a casing, in which the pouch cell like this is flexible polymer coated aluminum casing. You can easily find both in your cases, both cells, in your smartphone, laptop, camera, and so on. The other format is cylinder cell. For small scale application, you can easily find in tools, power tools, medical equipment, camera, so on and so forth. Please note that the basic structure of all of them is about similar, namely a jelly roll, or as known as a Swiss cake roll design. Consists of double-coated electrode layer that are wrapped around each other in a concentric spiral with a polymer separator layer between them. So for the larger application, it's well known as well, rechargeable lithium-ion battery are also extensively used for electric vehicle. There are two examples that I want to highlight for running around 85 kilometer range inside a Chevrolet model Gen 2 battery pack electric vehicle with 20 kilowatt hours capacity. You can find a battery pack inside, which consists of a total of almost 200 lithium-ion battery pouch cell in combined series and parallel configuration. On the other hand, for Tesla itself, introduced model as a vehicle with 100 kilowatt hour capacity that can run about 400 to 500 kilometer range use a battery pack that comes down to a total about 80,000 cylinder cell inside the car in both arrangement, serial, and parallel configuration. We can imagine with those so many cells, one of the cells is defective. Certainly, the performance of the electric vehicle is not more optimal. So, how does actually lithium-ion battery works? Let's see the animation to walk through you to the process. Battery is made up of anode, cathode, separator here in the middle, and also electrolyte, as well as positive and negative current collector. The anode and cathode store the lithium. The electrolyte carries positively charged ion from anode to cathode and vice versa to the separator. The movement of lithium ion creates a free electron in the anode, which create a charge at the positive current collector. The electric current then flows from the positive current collector from the device being powered, in this case electric vehicle, to the negative current collector. The separator also blocks the flow of the electron inside the battery. While the battery is discharging and providing an electric current, the anode releases lithium ion to the cathode, generating a flow of electron from one side to the other. When plugging to the device, like this case now, the opposite happens. Lithium ion battery are released to the cathode and received the anode. So this is the cross-sectional and topographical scanning electron at both left and right side are just to indicate the internal component at the interface of both current collector and anode, and also the cathode. Anyway, long battery run times have always been the wish for many customers. For running without loss, performance this device certainly need to survive during the charge and discharge cycling process for many countless time. Well, the issue is there. There are still extensive investigation to tackle a few challenges with lithium-ion battery cell, such as microcracking of the internal structure, the lamination of the electrodes, and the current collector, and so on. Another one is this one. The picture shows the pouch cell experience a gas swelling phenomena after cycling. Gas evolution in the lithium-ion battery is frequently observed as the result of variety of abuse conditions such as elevated temperature, overcharge, and overdischarge. This abuse condition degenerate internal material of the cell, which in turn lead to evolution of various gases such as oxygen, carbon dioxide, carbon monoxide, and methane. Gas evolution also regularly occurs as a part of the cell manufacturing process during formation cycle, where the cell is initially charged and discharged under carefully controlled condition. In cylindrical cell with rigid casing, gas evolution will give rise to increase in pressure, requiring some sort of venting mechanism to prevent catastrophic explosion of the battery. But in a sealed aluminum pouch cell, gas evolution will cause the flexible casing to swell, like this one, from a regular prism to a pillow-shaped geometry. So here I would like to present the work from my colleague Toby Bond and Jigang Cho. So although this gas swelling in the cell is routinely observed, the behavior of this electron jelly roll assembly inside the swollen cell has not been studied deeply. In order to image the deformation in geometry of the jelly roll, a non-destructive imaging technique is required. To achieve this, absorption contrast completed tomography technique is used on one of our beamline at the CLS. BIMIT here stands for biomedical imaging therapy beamline. Here is the X-ray used 30 to 40 kiloelectron volt impinged on the commercial pouch cell. Its image of which were taken before and after the discharge up to minus 500 milli-electron volt. The photograph here are only to show the gas swelling of aluminum and mylar cell is clearly possible, indicating that gas has been produced in the cell. It is believed that the gas produced is likely a combination of carbon dioxide, carbon monoxide, and methane. So here is the outcome. On the left figure is the CT image cell. Here, image of the cell itself is false color rendering show the jelly roll electrode assembly with the copper current collector overhang region clearly visible. And the heaviest element in the pouch are cobalt from the lithium cobalt oxygen 2 and the copper from the graphite current collector foil, both of which are significantly heavier than aluminum, carbon, fluorine, oxygen, and lithium, which comprise all remaining material in the cell. Figure on the right show cross-sectional taken from longitudinal center of the cell before and after overdischarge chart up to minus 100 millivolt. Comparing these two images, we can see that there is expansion along the vertical axis of the roll stack. Here we can see that this expand, increase gap between electron layer itself, because there are two electrode layers here, right? One negative, one positive. Also, we notice that there is very little displacement here around circular turn, round corner. And the other major noticeable feature is there is the greater displacement actually occurs in the area where there is already deformity in the jelly roll structure before over discharge of the cell. So already because of this deform here, it experience a larger deformation at the end. So this study actually demonstrates the use of synchrotron-based computed tomography to image the change in the geometry of the electrode assembly in a commercial pouch cell before and after evolution due to over discharge. This work will not be possible using conventional X-ray equipment. So I think I will move to the next topic, but I'm not sure, probably I already passed 30 minutes, so I can stop here actually. Or do you want me to continue? Do you want? Hello? Hello? Shall I continue? Is my voice clear enough? Or is connection still good? Hello, hello. So you still can, you still hear me well, okay. So shall I continue or just stop? Because I think it's already maybe past 30 minutes. Yeah, let's continue then. Yeah, maybe there are still, maybe there are 6 slides left actually. Okay, but the second topic is, okay, the host is maybe have some problems, I see. Okay, I will continue a little bit maybe, but the second one is more fundamental science, so no problem. But I will start with the, of course, with the motivation itself. So the next topic is about superconductor. So from sustainable energy to quantum computer, high temperature superconductor have the potential to revolutionize today's technologies. Here are a few examples of their application. Some are commercially available, like for this one, like for this one is quantum computer from the Canadian D-Wave company, or magnetic resonance imaging, where you can easily find in hospital. Some are still ongoing projects, such as superconducting magnetic levitation train, also power transmission line. Yet many installation of short distance superconducting line happen in many countries. Uh, So here are a few of here are a few of the example, right? So for that, most of these superconducting material used in this application are niobium alloy based, such as chips in the quantum computer or superconducting coil in magnetic resonance imaging, like this, and so on, which require cooling either by helium gas or hydrogen liquid. For the transmission line, although some of them use bismuth-based cuprate, the main challenge for not yet widely used is still a higher cost for the cryogenic envelope and cooling system. So it's not yet economically competitive to the standard product. Despite intensive research, however, we still lack of necessary basic understanding to develop this complex material for widespread and sustainable application. There is a message here. Yeah, okay, let's see. If I stop sharing first and turn off my virtual back. Let me stop my video. Okay, sorry about that.
I think the MC or the moderator is having issue with the microphone. I will contact them first.
Yeah, no problem. But here also have some problem with my.
Yeah. Because you have the limited CPU, I think the monitoring the CPU of your computer is 100%.
Yeah.
So Buat, yeah, you can continue.
I need to the share content button is not yet is still disabled. Probably I will disable my video then also. I don't see my share. Okay. Thank you. Let's see if I can continue a little bit. So,
Yes, we can see your screen now.
okay, yeah. Thank you. Okay. So yeah, this is just a review of the timeline of superconducting critical temperature below which the material becomes superconductor for variety of superconducting material. Since first discovery in 1911, the color itself represents different classes of superconducting material. There is this dark green circle for pure metal and niobium alloy. This is the diamond, blue diamond one is copper oxide cuprate, and so on and so forth. This one, right? So in 2005, of course, there is the discovery of iron-based superconductor also sparked a new interest in the field of superconductivity, although its application is still under scrutiny as it requires an arsenic component to function. Recently, there exists new record for superconductor with the highest TC up to this. Let's say, for instance, there are two examples here: hydrogen sulfide TC of 200 in 2005 and lanthanum decahydride about 260 K last year actually. But both of these materials need a high pressure to be superconducting. So at the moment, I'm not sure whether it is applicable or not. I would say that it seems that the cuprate, so this one, are still favorite playground for a basic and applied research in the aim of deeper understanding of superconducting mechanism and finding a route to get room temperature superconductor. So yeah, I will skip this, or I can mention this a little bit. The motivation about why is cuprate or copper-based superconductor interesting.
Perkenalkan, nama saya Muhammad Fajar Yanto. Saya akan membacakan cerita pendek. Coronavirus or as now as COVID-19 or 2019. Cough is up.
Okay, copper oxide by itself is a very fascinating but also extremely complex subject of research. Complex oxide as its main building block of the cuprate seem to dominate the low energy physics, which in turn exhibit a rich electronic property as shown in the phase diagram here. To study about it, it requires development of a new technique at both theoretical and experimental level. This is where one of the beamline techniques of resonant X-ray scattering is able to play important role. It is X-ray in, X-ray out, which is energy is tuned to sit, so to speak, at the resonance of the constituent energy level. In this particular case, it corresponds to the energy of copper 2D and 3D orbital. So here are the outcome. Let's say, let me start because this is a YBCO, yttrium. There are yttrium, barium, cuprate, and oxygen. The rich electronic properties ranging from antiferromagnetic insulator to from the parent compound to the metallic phase. by the high doping. The superconducting dome exists here in the middle doping range. There is also a pseudo gap in the underdoped region, above which critical temperature of the superconductor and the superconductor has TC maximum about 95 Kelvin and the oxygen of 6.93 or whole doping or 0.70. The issue are here are what is the nature of pseudo gap? Does it purely charge ordering or different? If this is charge ordering, how does it behave with respect to the superconductor? See. So here are the outcome in principle. As a background information, so yeah, the top left figure is the scattering geometry itself, where the crystallographic axis of the sample is aligned with the polarization of the beam. So experimentally, we do this at the Rex beamline, resonant elastic inelastic X-ray scattering with the energy of 130 electron volt. We just basically do rocking the sample around this y-axis. As you can see here, the bottom left panel, normalized intensity of the versus scattering factor as a function of temperature. As you can see, while we go down, the CDW peak axis, but it's not go all the way increase. At some point, decrease again, around 60 up, and then at 30 go down again. So this is first observation of charge ordering in the cuprate. Appear at a higher temperature than TC, and it seems it competes with the superconductivity when it is below TC, right? So I think fast forward, this charge ordering phenomena is not only observed in yttrium-based cuprate, but also in other compound like lanthanum-based cuprate. This is the yttrium-based cuprate. Actually, this is the bismuth and mercury-based also. So all cuprate, it seems, at least in the whole dome, show this charge ordering phenomenon. So if we go back to the first question of this, whether there is a kind of universality in this compound, the answer is yes. At least for the whole dome, charge ordering is now accepted as an integral constituent of the cuprate ITC superconductor, one that is intimately related to other electronic instability, including antiferromagnetism and superconductivity. Similarly, all of this work can only be done using synchrotron light and specifically with only resonance of X-ray scattering. I think I will end my talk with that. So to recap, I have shown you what is about synchrotron light. So this is a kind of powerful tool for conducting many research areas for both basic and applied science. At the cell itself, we focus on agriculture, health, environment, and material. I've shown you also two examples for the sustainable energy battery about research in a lithium-ion battery and also the copper-based superconductor. With this, I would like to acknowledge my CLS operating funding agency, which is Canadian Foundation Innovation, Natural Science and Engineering Research Council, this one, and National Research Council, also Canadian Institute of Health Research, Government of Saskatchewan, and University of Saskatchewan. For this presentation, I also would like to thank my colleague Bibon and Jigang Cho for the lithium battery works, and also Giacomo Gringelli and Andrew Acker and David for the collaborative work on the copper-based superconductor. Okay, I apologize for the technical difficulty as well from here, and thank you for your kind attention. So I will stop my share.
This year. Okay, thank you, Mr. Roni Sutato, for the presentation. We also like to apologize for the technical difficulties as well. maybe during the presentation, the audio from here is not really well here. I would like to highlight the
Okay, no
presentation
problem.
from Mr. Ronnie. It is simple yet deep and comprehensive about how synchrotron lights works and why is it so special, along with the showcase of a few examples in some areas such as the health, advanced materials, and agriculture. It is quite impressive though that among around 50 synchrotrons around the world, the Canadian light source is the only one of its kind in Canada. We do have some questions, but I think we will save it for Q&A sessions later if you don't mind. So please stay with us. And now I would like to invite our third speakers, Miss Agnes from Infineon Technologies, who will join us with the presentation of making more out of less for a sustainable future.
Hi, good morning.
Good
Selamat
morning.
pagi.
Selamat pagi.
So let me share my screen.
Yep.
Can
It's
you
coming
all
right
see
now.
my screen?
Yep. It's coming up right now.
Yes.
Perfect.
Okay, so let me just set it up in. Okay, so now I need to change the display also. Wait, because the bar is disturbing me here at my side. Okay, now it's coming. Duplicate show. So now should be hopefully correct at your side. Can you see it also in only one slide? Okay, very good. Thanks. Then I will start my presentation and sharing. Is the sounds also good enough?
Yes, very clear.
Okay, perfect. Then let me start. So good morning, everyone. So my name is Agnes. I am head of R&D at Infineon Singapore, taking care for packaging development for Singapore and Batam, but also recently focusing also on Korea. So I am working now since 20 years in semiconductor industry. I started my career with Infineon back in Germany and had the chance and the opportunity to work on various projects in various countries in Germany, France, Malaysia, Taiwan, and China, which was a quite enriching and fulfilling experience. Before I joined Singapore, I was part of the business line automotive and taking care of the powertrain and safety portfolio. I am French, so I graduated in France from NCCAR, and I focused during my study on microelectronics, and I hold a master degree in microelectronics. Let me also introduce briefly Infineon. So sorry. Okay, so let me introduce briefly Infineon. So Infineon has a focus on 4 key fields in the industry, and we support with semiconductors the automotive business. We support also industrial power control, where we have quite a lot of solution for power management. Also some solution for power and sensor systems. And last but not least, a strong focus also on connected secure systems, which is mainly related to safety and measures. We are now, meanwhile, grown a lot. So we are 47,000 worldwide, quite a lot in Asia, like you can see, 23,000 in Asia. We are constantly growing, and our market position is very strong in automotive and power, and also in security IC. So I have been very honored to be invited to share today. And I find so team choose for this year very appealing. And then shaping a better future through sustainable technology was for me something where I was really thinking, this is really a great topic, because this is where we as engineers can use our technology to be a driver for sustainability. And in the past, technology was quite often associated with disruption and also not friendly to the human being, or not all human being. And then I really like this approach to shape a better future, and then with a sustainable technology. What I also like really in this team and is that we are in the driver with the word shaping, is meaning it's appeal me that I can do something. And having 2 kids is also very important to me to leave to them also a sustainable world or a better future. So in today's presentation, I will focus on few key items. So I will reflect first on today's mega trend that we observe worldwide, which are impacting all of us and which have a driver for us to move. Secondly, I will share 2 examples of semiconductor solution for a better future, and I will focus first on smart cities and smart lighting especially, and give a bit of explanation on semiconductor in electrical vehicle. Then moving ahead, I would like also to share a bit that it's not only application which can sustain a better future, but that the basis technologies and the innovation we are doing are the basis for greener products. And last but not least, also what is our responsibility as company, but also as individual, so that we are the driver for sustainable technologies. So let me guide you through this. First, today mega trend. So first of all, what do we observe and which are the mega trends that also increase the needs for microelectronic and semiconductor? So today we are 7 billion on Earth. We expect to be 9 billion by 2050. So we see a major demographic change and social change, which have also certain constraints. We already know and we already observe the climate change and the resource scarcity, but with increased population, definitely it will become even more a focus than today. We see also the increase of the urbanization, and meaning we need also to manage our cities accordingly. And last but not least, we see that more and more things are going digitalized, and the digital transformation is now accelerated when you look through the COVID pandemic. So, from these 4 key trends, which are the key areas that the semiconductor will follow and will support especially, or will be a basis also for improvement and growth? First one will be energy efficiency. So here you see the nice picture of renewable energy with wind. And definitely you need a semiconductor device here to convert so wind and so DC, which is generated in a AC power. And this is where semiconductor and especially power semiconductor are very important. And the efficiency is also very important, also to not have losses and to not impact also the productivity here of the system. Then the mobility, by being more, so mobility become even more complicated and difficult. We need also to have a green mobility to reduce our CO2 emission, and also we need to manage also the flow of mobility. So this is where also semiconductor offer some solutions to manage all these problematics. Security is very important. Going more digital means also that you will have more, for example, online payment, but for sure you want to have it secure, and this is where you need secure solutions. And last but not least, we need also to manage the big amount of data that we are generated here by having more digitalization. So meaning we see some trends, we see also key areas where semiconductor will grow and where semiconductor become more and more important and will be a vehicle also to have an innovation which is supporting a better future for all of us. So now let me share 2 examples just to make it a bit more concrete. Where can we use semiconductor and how can we use semiconductor? So let me start first with the smart cities. So as I mentioned, so population is growing and also the population is growing in the cities. So by 2022, 56% of the world population will live in city and even more in 2050 where we come above 60%. So meaning we say 9 billion. So you can imagine 4.5 billion in cities. So what does it mean for challenges? First, we have really to manage the population density. We have to manage also the increase in traffic and usage of overall infrastructure. And last but not least, very important to have a higher standard for security when you have so many people in a so small area. So now, how can a smart city help us to overcome all our challenge? Here are some examples. You can have some traffic management support, you can have some parking control, some emergency response, which are very important. So higher the density is. You can have also environment monitoring, and this is true enough that major big cities have also already implemented measures to control also the environment. And last but not least, warning and alerts and crime detection. And what will the smart city needs? Definitely, they will need to collect a lot of data, to digitalize the technology, to improve our quality of life, and are putting in some more intelligent. Now let me come to the example I wanted to share, which I think is very close to each of us, and which is a smart lighting. So lighting is something not new. So we have it in all cities, and it's very important also to cover all major traffics also for safety reasons for all of us. When you take a normal light today, so it goes on about when the sun go down, let's say 7 p.m. Singapore time, and it's go down in the morning also 7 a.m. Singapore time, a bit differently in Batam because the time is a bit different. And how can we use this lamp to support the day-to-day life organization? So what can be done is to add some sensor and connectivity solution and make them smart. And let me give you some example. So this is an example of a smart lamp, which is already in place in few cities, I will share later, where you can add some semiconductors that you see here, like sensors, LED lighting, and some connectivity, and you get some more features in so like for example, traffic flow optimization by sending some information on the traffic, parking detection. Something very important for energy saving and energy consumption, dimming according to the presence detection. So meaning you have no pedestrian, you have nobody on the street, why to keep the lamp on? System like sensor can help you to dim it and turn it fully on again when you have people coming close to the lamp. Crowd management, city planning, and also implement inside some air quality monitoring through sensors. So definitely you have cost saving, especially when you manage the energy system. You better understand the infrastructure because you can see also when a lamp is not working, you can also monitor the performance and replace just in time instead of making a change when a bit earlier. And you can also improve the day-to-day quality of life of all of us. So good point with these smart lights is the sensor and the add-on components don't afford that you always change your lamps. It's the add-on you can put on at a quite low cost just to improve the day-to-day life. Here's some example of cities who have already implemented it today. So Hong Kong have it. This was also awarded by the government as an outstanding solution. Shanghai also use it with some LED light monitoring also, and vehicle flow traffic, Taipei, and we have it also here in Singapore in various area, and to use it also for collecting data and use it for analytics on the city. So let me come to a second example, which is electrical vehicle. So here we all hear on CO2 consumption, CO2 emission, that industry is polluting and also damaging our environment. And environment is definitely something that we need for our future generation and that we need to preserve for the future generation. Here, what you see on the graph is so CO2 emission over the time, over the years for different regions. So green and orange are US and China, whereas red and yellow are Europe and Japan. So you see that over the years, definitely the CO2 emission reduced due to the new technologies implementing in cars, like powertrain system to have an optimized consumption of fuel. However, what do you observe? First thing's very interesting. You see now that the CO2 consumption for all countries is now converging. What we see also is that it's become quite stagnant. So what happened now? So what we see is, first of all, the authorities in Europe are pushing down the CO2 emission and putting in place some regulations so that we really tremendously reduce by more than 30% the emission by 2030. So this is one point. Definitely, we know that we have to move and we have to change also the way we produce car for that. And what we see also is that we will have to implement more full electrical cars, so what we call here BEV, and also hybrid car to manage that. Because if we stay in the situation we are today, it will not be possible because we are already stagnant. So these are some various technologies adopted to reduce the CO2 emissions. So increasing the battery voltage from 24 volt to 48 volt to have more efficient hybrid solutions. You need some charging station and some electrical car. Just before we talk also on the Lion battery, so I think here also an application for electrical car, where you see electrical car will need a charging station, we'll need a battery, we'll need different motor, and all that will require also semiconductor solution and application. And you can see here some bus. I already also electrical bus in certain cities, and will also require the same system and knowing also the constraints of a big vehicle compared to normal vehicle. So now this chart is interesting, and what is the chart showing is showing that the more electrify is the car, so more you need electronics. So here you have the 48 volt battery systems, which are for hybrid cars, and here you have the full electrical car. Here you see the different content of power semiconductor, and you see that the total semiconductor BOM will increase tremendously depending on which electrical vehicle you need. And you can see that for getting a green car, you need more and more semiconductor content and power semiconductor content. So now, before I move to the next chapter, maybe a short talks on what we are doing here in Batam, also with the team. In the team, we are also supporting green applications. So we are developing packaging for products which are creating a link between a high voltage domain and low voltage domain. And main application are, for example, for transforming so DC current from the wind to AC current, solar panel conversion, also electrical cars, and so on and so on. So meaning here also in Batam, we are supporting this kind of green energy. And I wanted to mention it because I think it's quite important to know also what happened here locally. So now I have shared the mega trends. So we see that definitely We have some changes. Our demographic trends is growing. We have some urbanization which will not stop. We have definitely a climate change, and we have to focus on how to manage our resources, and last but not least, digitalization. We see also that applications like smart lighting, electrical vehicle will require technologies like semiconductors, and also will support us to have a greener product and a better future. But before, what do we need? Before we have an application, we need also technologies. And being an engineer and being an R&D head, I would like to share to you how can innovation and technology be the basis, and why do we need really to innovate and to focus on technology for having greener products? Here, just a short introduction on our power semiconductor, and Infineon is a strong focus on power semiconductor. So power switch is very simple. It's a simple transistor. When it's on, the current flow. When it's off, the current is blocked. So to adopt the new application and the need of the market, we need constantly to move. This is something which started long ago. And what you see here, this is a module we are using today, which are well known on the IGBTs. But to cope with the new needs of electrical cars, for the commutation of data, high speed of data, high switching frequency, we need new technologies. And the technologies we are using will support us. You have the silicon carbide coming in, where you see the power handling is quite high and the switching frequency is higher than the standard IGBT technology. And this will be very important to support electrical power module for electrical cars. High friction frequency will be very important also when you have more data exchange, where also here gallium nitride will also support. So these are basic technologies. Now, how does it support first application? Yes. Second, how can it make our application even more sustainable? So you have one aspect, this is really the performance and the technology to cope with the increase of needs in the technology. But the second aspect is how to make my technology more and more efficient, so that you have less power losses. So if you have less power losses, you need less energy. So then you have less emission, and you also less deplete our resources worldwide. So meaning quite an important aspect also to consider. So here you see the turn on losses of our IGBT module and coming now to our silicon carbide over time. And you see that we really, by incrementing our technology, reduce power losses. And this is very important to engage yourself and to constantly innovate, to have a basic technology which is very efficient, so that your application also will support less energy consumption, less power consumption. So I have shared briefly. So now I would like to come to companies and individuals, and how are we in the driver's seat for a sustainable technology. Here I would like to share some gathering we have from our team members, from employees from Infineon worldwide, just to give you a glance how they see themselves and how they contribute and want to contribute to a better future. Here's an example of Andreas. He's working here on radar system, and he's very proud that he's providing radar solution so that you can detect when somebody enter a room, and so light will go on and go off automatically, which is also, for example, an application I explained also in the smart lighting, which will really improve also the resource management and avoid waste. Miss Avni here, who is working in our microcontroller team, and who is very proud also because the microcontroller will manage also signal from the sensors and will also help to prevent accidents by managing the car system, yeah, and activating the emergency brake system. Another example from Thomas, which is more working here on modules, and very proud also to support the rise of e-mobility. And this is what I mean. I think when you believe in it, then you will also have the willingness, and you will also focus when you work on your day-to-day to develop new products which will also fulfill a better future. Now coming to the companies. So Infineon has engaged itself for ecological actions. And what is very important, first is the way you produce. So you can decide also the way you produce. And we definitely have implemented here a clear target for us to be carbon neutral by 2030. And how we do that, for example, also transfer also energy consumption to a green energy. So really take green energy sources, reinforce also more and more recycling, etc. But this is definitely a company target and guideline and engagement. Important also is that we engage ourselves also to create products and to drive innovation to have products which are efficient and will support climate protection and energy efficiency and resource management. As I mentioned before, you need to engage yourself, and companies also have to engage themselves. And CO2 neutrality, we can contribute and we have to drive it and also push for it and make it happen with a clear roadmap and monitor it. I will share also here the vision and mission of Infineon, because I think it's also what we all believe when we come in the morning in the office. And this is where I say we are in the driver's seat. We want to be the digital link between the real and digital world, because we know today a lot happens digitally. And how we want to do it, and what is our mission? Our mission is to make life easier, safer, greener. If you believe in it, you will also apply it in what you do and also bring more and more solutions which will fulfill. So which are the key takeaways? First, there is no doubt about it, sustainability is key for our future. We need to preserve our environment, and we need to preserve our society. Application based on semiconductor reduce energy consumption and offer solution for a better future. There is also no doubt about it. And there is also no doubt that we will need more and more semiconductors applications to support the development of the technology. But before we can do applications, we need really to innovate and spend effort on our base technologies so that we can develop sustainable solutions. And last but not least, I truly believe, and also for myself and also for my department, that this is our responsibility to shape a better future and that we are in the driver's seat. Saying that, I am at the end of my presentation.
Thank you, Ms. Agnes, for the presentation. It is a bold and strong statement that the only way to master the climate change for a sustainable future is when all the stakeholders in our society, that is, company and individuals, act jointly, decisively, and courageously. Our honorable speakers and all participants, due to the time difference between Indonesia and Canada, Mr. Ronnie couldn't join us until the end of the session. So I would like to have an early discussion with Mr. Ronnie. Then we will continue to our last keynote speaker, Mr. Rosaimi. Hello, Mr. Ronnie.
Yes.
Okay, do you have anything to present to the participants?
I think if all you already share well my voice well before, and the slide also is not frozen, I think it's always good from my side.
Okay, thank you.
So what I mean, no more additional presentation. What I mean is already being covered.
Okay, thank you. So I would like to ask from your experience in Canada, light source from the map that you show us in the introduction. If I'm not mistaken, there is none of synchrotron development in Indonesia yet until now. If I'm not wrong.
Yeah.
So
yes, correct.
Based on your experience, what is the biggest challenge to bring this development in Indonesia? Because from your presentation, we can conclude that there are a lot of benefits actually, despite all the challenge later. What is the biggest challenge to develop this synchrotron in Indonesia, based on your experience in Canada like source?
Yes, I think to build synchrotron, I think to gather all many stakeholder, not only from governmental side, but also all from the academia, what I mean, and then also from the industrial partner as well, because the one for the history of Canadian light source itself, it started I think from 1998. So some of the Canadian researcher try to conduct experiment in the neighborhood synchrotron. What I mean neighborhood is in a United States, right? From small group first, small group researcher, and then start to develop interest, getting bigger and bigger, and then at some point, they discuss to build it in Canada itself. So it takes years and years to build this. What I mean, but afterward, there are a lot of stuff. What I mean, like feasibility study and then technical conceptual design, everything. So it's the what I mean from my point of view, the maybe the biggest problem is there. What I mean, should gather all the interest from many stakeholder first, and then of course afterward the funding itself, the budget, right? The funding, the budget is quite the cost is quite high, of course, to build that, but afterward the benefit is what I mean is more compared to the cost itself, because a lot of expertise will join into this project, right? Not only from scientists itself, but also from engineer, how to build the building, which is less vibration, which can stand for the, let's say, but probably the problem in Indonesia also, I think, the power lines as well. I do not know. We need a stable power as well, right? We need from the engine, electrical point of view. So yeah, quite a lot of stuff. But I mean, my view might be maybe only small. I only look from the scientific side.
So in conclusion, it is actually quite a strong process. It needs years and years investment, not only in the budget but also in the people, in the source, infrastructure, and etc. We do hope that in Indonesia, we believe we will get there maybe someday.
Yes.
So Ronnie, we have another
Actually, maybe it's good because, yeah, pardon.
Yeah, it's okay. You can.
Yeah, probably because there are already some synchrotron exist around the world, right? So I mean the knowledge transfer is there. Typically, synchrotron people are willing to share all their knowledge, their experience, right? So because the older generation of synchrotron, typically they already gain fails more compared to succeed. So we can learn from them as well, typically like that, right? So it's a different. If I hear the first speaker or yeah from Diana, maybe in science world typically I'm not sure, maybe in an engineering side maybe different, but in a science side typically we just share like this the information about the scientific finding without any intellectual property, right? So it's different in different philosophy. What I mean, we can learn from them. We can learn from all of the experienced people. That's the good thing. If at some point Indonesia want to build that. Right? Yeah. Yes, yes. Yes. Sorry, can you repeat the question? Yeah, from Mr. Daniel Sutoko. Sorry, once again. I think I know the problem now because the video is giving me problem. Yeah, so I will switch off that. Yes, with also with the virtual background. Mhm. Yeah. No, actually, the small laboratory scale impossible because I think that is the, let's say, the prime advantages of the synchrotron, right? Because the light that is produced is covering broad spectrum and also quite high intense. I don't think it can be built in a laboratory scale. That's why it's what I mean is need to be a national research. It's need to be national research for the first synchrotron like that. But afterward, like in a United States or some in I believe no in Germany not. I think in United States some of university has their own relatively small synchrotron, but most likely one country only has one or two national research for the big one, what I mean, because yeah, I think this is like many research institution join into one research facility. So what is the big infrastructure? Yeah, you need to find appropriate land, right? First land location, what I mean, location where, let's say, not so many vibration.
Okay, so we can say that we need a big start to build
You can start from there, from the beginning.
Yep, we need a big, whole, and comprehensive from all the stakeholders to start
Yeah.
the synchronous research. That's the conclusion, right?
Yes.
Okay, do we still have another question for Mr. Ronnie? I think that's enough question, or do you want to add anything?
No, I think I'm fine. Just once again, thank you for your kind invitation. So sorry for the technical glitch. I hope that all of you can hear or learn something from my talk before, right? Okay, I think that's all. Okay. Yeah, thank you, and enjoy the meeting and stay safe. Yeah.
Okay, now we will proceed to our last speakers. I would like to invite Professor Jose Michi Hassan from University of Technology Malaysia to deliver the presentation.
Hello, hi, good afternoon. Can you hear me?
Yep, we can hear you clearly.
Yes, clear Pak.
Okay. Okay, terima kasih. Okay, I will share the slides first. Just a moment.
Tadi habis video suaraku kan masuk ya. Barusan.
Okay, can you see the slides?
Yeah, we can see the
Can you all
slides.
see the slides?
I mean,
I'm sharing.
yeah,
Yes, sir.
you can see it.
Okay, okay. Assalamualaikum and good afternoon.
Waalaikumsalam.
From Kuala Lumpur, my name is Rozaimi. And here it is now 11:46 a.m. Okay.
Sorry, sir. This is morning, not afternoon, sir.
Yes, yes, yes. It's already afternoon in KL. Okay. Okay. Let me. Okay. Okay, I'm from Razak Faculty of Technology and Informatics, University Technology Malaysia, Kuala Lumpur. Okay, here is some pictures of from the campus. We are located close to the Kuala Lumpur city, and you can even see the twin towers from the faculty, from the university. Okay. I have only 25 slides, and it won't take much of your time. I think I can finish this very quick. Okay, so the topic that I'm going to talk is about the conservation of marine resources. Okay, using the marine habitat mapping or benthic habitat mapping. Okay. The purpose is actually to support one of the sustainable development goal, number 14, which is life below water. And what I'm going to present is basically the integration between the hydrography and acoustic marine acoustic data with the machine learning technique to produce a marine habitat map. So what we can do with this data and machine learning technique to produce a habitat map which we can use to assist and to support the SDG, which is number 14, which is life below water. Okay. And for introduction, I think most of us are aware that there are many sustainable developmental goals that has been developed, and one of them is the number 14, which is life below water. And I think most of us are aware that we are depending on our marine and coastal biodiversity for example, for the marine resources and also for the economy. And we also need to aware that until now, 30% of the world's fish stock are overexploited, and then we need to do something about this. And also the ocean generally absorb about 30% of the carbon dioxide produced by humans. And now we know that 20%, there has been 26% rise in ocean acidification since the beginning of the Industrial Revolution. That's why we need to do something about the marine. And the SDG, which is what has been developed, aim to sustainably manage and protect marine and coastal ecosystem from pollution, as well as to address the impacts of ocean acidification. Okay, and also enhancing conservation and the sustainable use of ocean-based resources through international law will also help mitigate some of the challenges facing our oceans. Okay, and also among the SDG goals is number 14. Okay, number 14 is to use and preserve marine resources and also to avoid extreme anthropogenic activities. And how we can manage the ocean. Okay, there are many steps, there are many things that we can do, but one of the things that we can do is that we can collect all information about the marine habitats and put them in a proper maps. Okay, so it's what we call it as habitat maps. Okay, before we want to conserve, we need to know all the information about the marine habitats. Okay, and also to sample entire region or to collect information about marine habitats for the entire, for example, in Malaysia coastline, it's very difficult and also impossible. And because of that, we need some sort of method to remotely collect data, okay, and produce a more spatially explicit map from the acoustic data, which means that we need to think about how we can minimize the sampling by using the remote technique to collect the habitat, to produce habitat maps. Okay, and also if we derive the we have the biological data such as species, community, or marine habitats information. If we can combine with the acoustic information, such as from the sonar data, we can make some maps or predictions where we don't have direct measurements. Okay, so in these slides, okay, in this presentation, I will highlight some of the techniques that we can use to produce biological map, or specifically or what we call it as a marine habitat maps. Okay, what we can do is we can use hydrographic data, okay, from the such as from the sonar data, and also we can use the biological or species information from underwater video, diving, and scuba, and also underwater transect, and we can combine this with machine learning technique to produce a more meaningful marine habitat map. For example, this map showing different types of habitats at different colors, so we can know accurately the spatial location, and also we can know the for example this coral is distributed at the specific areas. Once we have this, we can it will help us to manage and also to help the marine managers or marine authorities to manage their coastal efficiently. Okay, a little bit about hydrography. I think maybe some of you know about this. Hydrography is a science field that involves measuring the depth of the water. Okay, generally measuring the depth of the water, and also map all the navigational hazards located on the seafloor, such as wrecks and rocks. Okay, this is, I think, any country that has the coastal area will have the hydrographic authority that produce the navigational charts and so on. And from this data collected from the hydrographic technique, that they can produce navigational charts and mainly used for the safety of navigation. And the technique to use the technique to capture the data can be done using the sonars, and also some use the lasers, and some also use the satellite observation for the shallow water. For example, areas with less than 5 meters, you can derive the depths from the satellite observation. But in this presentation, I will focus on the data that has been collected using sonar, underwater acoustic sonar. Okay, and also hydrography also involve with measuring the tidals. Okay, the tidal and also the currents. A little bit of definition from the International Hydrographic Organization. Okay, hydrography is a branch of applied sciences. Okay, which deal with the measurement and description of the physical features of the oceans, seas, coastal area, lakes, and river. Okay, and also study of the prediction of the change over time. Primarily for the safety of navigation and in support of all other marine activities. Okay, primarily used for the safety of navigation. Okay, and also for to assist all the other marine activities. Okay, in the coastal and also in the ocean, and also including the economic development, security and defense, scientific research, and environmental protection. So what I'm going to highlight here is that how hydrographic data can be used or can be manipulated. The data can be manipulated to be used for environmental protection and conservation of the marine habitats. Okay. A little bit about machine learning. Okay, I think most of us know, aware of machine learning. Machine learning is a branch of artificial intelligence, a science that researches machine to acquire new knowledge and new skills and to identify existing knowledge. Okay, I think machine learning we can learn something new from the existing data from the machine learning. And in this study, okay, we would like to train machine learning using a combination of acoustic data or the data from the hydrographic data or the data recorded from the sonar system, coupled with the ground truth data. And we can use this data to predict or classify areas where the direct ground truth data is not available. So we can use data, physical data, combination of physical data and also the ground truth data, and we can use it to predict where the ground truth data is not available. So we can use machine learning to come out with the full coverage of the habitat maps, marine habitat map. Okay, I think machine learning, there are many types of machine learning. There are unsupervised technique, which is you can do some clustering without any training. You can also use the unsupervised learning method for if you have too many hundreds of variables, you can use it for dimensional reduction. And also you can also use machine learning as a regression technique, such as supervised learning regression. And the one that I'm using is I will be focusing on the supervised learning for classification. Okay, so we will train the machine learning, and then we will use the physical data, which is from the acoustic data, and also the ground truth data, so that we can classify a new set of data where direct measurement or ground truth is not available. Okay, And there are in machine learning there are many types of the techniques. There are different types of algorithm, and one of them is the what we call as a random forest decision tree. Okay, this is one of the machine learning algorithm. It used basically it used the concept of classification or prediction using the decision tree. Okay, but compared to normal decision tree, random forest is a method that depending on that it creates many decision tree, and then every trees will vote for a class, and for each class there will be for each tree there will be voting. Okay, there will be voting, and the class that has the highest voting will be used as a prediction class. Okay, so for example, for in the first step, the random forest will generate will start with the selection of the random samples, okay, from a given data set. Okay, that's why it's called as random. So from the sample it will select the random samples, and the step number 2 is um, uh, this algorithm will construct a decision tree for each sample. Okay, and each tree will have the prediction. Okay, and step number 3, a voting technique will be used to vote for each. For example, you have 5 classes, so each class will have their own votes. Okay, and for each class that has the highest vote, it will be selected as the prediction, as the predicted result. And step number 4, select the most voted prediction as the final prediction result. Okay, so means that it uses the concept of decision tree, but it is much more advanced in terms of selecting random samples and generate many decision tree, but use the voting concept. Okay, and also in this presentation, I will show you how we can use the data from the hydrographic survey data, which has been collected using the multi-beam echo sounder sonar system. Okay, one of the sonar that has been mainly used for charting purposes, for getting the depths of the seafloor and produce the navigational charts. Okay, the advantage of this multi-beam echo sonar system is that it use for one system it use the concept of many beams. Okay, many beams, and therefore we can get hundreds of beams. Okay, typically we can get about 500 12 512 beams at one time. So if we do survey and measure the sea floor, every second that we can get like full coverage of the sea floor depths, water depths, and also we can get a good spatial resolution from the data. So this is an example of the data we can get from the sonar. We can get the bathymetry. Okay, this is the example of the how the sonar swath coverage looks like. Okay, and also this is the one of the product here is the bathymetry, or the depths, the water depths. And from this multi-beam sonar, we not only can get the 3-dimensional of the bathymetry of the seafloor bathymetry, but we can also get the another set of data, which is what we call as a reflectivity map or reflectivity data. And reflectivity with that map, or what we call as a backscatter. Okay, so from a single survey we can capture the depth data, and also it also recorded the reflectivity data, which is backscatter. Backscatter is the amount of energy reflected by different types of the seafloor. Basically, normally measure in the decibel, okay, because it use the sound, acoustic sound to send the acoustic wave, okay. And so we have we can have the depth data, and also the depths will highlight will represent the water depths, okay, the seafloor water depths. And the different intensity of backscatter or reflectivity will highlight the different types of we can use it as a proxy to highlight. For example, highest intensity can be captured or can be recorded from the seafloor surface that has some sort like gravel or rocks, seafloor types, sediment type. Lower reflectivity or intensity might be possibly from the fine sand or clay sediment type. Okay, so we can use this. It's not a direct measurement, but we can use this as a proxy to infer the marine habitat. For example, the different types of sediments, and also different types of habitats such as corals, seagrass, seagrass bed, algae, and so on. Okay, in this presentation, I will be using this data. Some of the habitat is I will be showing some of the only corals, coral, and also a few types of sediment. Okay, so this is the one of the data collected at the Redam Marine Park. It's a marine park in Malaysia. It's a marine park. Okay. Before this, we haven't got any information of the seafloor depths, and also the intensity, and also the coral distribution of this area. So we collaborated with the marine park, the Malaysian Marine Park, and also the Hydrographic office in Malaysia, which is National Hydrographic Center. And we managed to collect to acquire the multi-beam sonar data at this area, okay, to develop or to produce the marine habitat maps. Okay, so this is one of the data, which is the bathymetry or the depth. Okay, so we can see that the depth here is like 0 to almost 60 meter. 59 minus 59 means that it is below the water surface. Okay, 0 to 60 meter. Okay, this is what we can get from the we can get full coverage and good spatial resolution of data, except for the areas that are quite shallow. Okay, the vessel that we use, the survey vessel we use, cannot go up to the close to the shoreline. So we have some gaps there. Okay, we have some gaps because of the shallow area. Okay, this is the bathymetry, and from the bathymetry, because we are going to produce habitat map, we also need to produce from the bathymetry. We need to produce some additional information. for example, okay, for example, the slope, okay, the slope can be derived from the bathymetry, which is, this is the bathymetry slope, because, for example, if you are looking at the corals, okay, you can differentiate between corals and plain sandy sediment using the slope information, okay. The slope information, the slope value will be different between the sandy sediment and also the coral area. So one of them is the slope. And then from the bathymetry, we also derive the additional data, which is Verigosity, okay, a measure of structural complexity represented by the ratio of surface area to plane area. So this is Verigosity. It will produce another set of data from the bathymetry, which represent the Verigosity of the area. And also, we also produce the bathymetric position index, okay, bathymetric position index, which is it compares the elevation of each cell in the bathymetric.
Udah koin
May I continue? Okay. Okay, and also the aspect. Okay, aspect is the describe the azimuthal direction of the steeper slope. Okay, this is the azimuth of the slope. Aspect, the steeper slope. Okay, azimuth of the steeper slope. Okay, this is some of the maps. Okay, we have the slope map. Okay, for example, 0 to 90 degrees. Okay, you can see the plane area and also the slope, the high slope is indicated by the red color. And also we have the benthic position in that. Okay, most likely the red most likely is will be occupied by some habitats. And also another set of data, okay, from the apart from the bathymetry, we also have the backscatter or the intensity data. Okay, the reflectivity is about 10 decibel, minus 66 decibel to 10 decibel. Okay, this is the reflectivity, the intensity of the area. So the different intensity, the high and low intensity, most likely will represent different types of sediment. Okay, smooth sediments and hard sediments like rocks will have different values of intensity. Okay, we use it as a proxy to predict the coral and also the sediment types. Okay, and also from the backscatter reflectivity data, we also can derive extra information or extra layer from the backscatter, which is, for example, the synthetic color image. Okay, most originally used in the interpretation of the radar image. Okay, and also we can use the other statistic from the or what we call as textural properties from the image. We use gray level co-occurrence matrices. I think most of us who involved in image processing and image analysis will came through about this gray level co-occurrence matrices. For example, the measure of homogeneity, entropy, correlation, the mean value, and so on. So this is a measure of statistical properties that we can get from the texture pattern from the backscatter intensity. And most of this technique has been used in terrestrial remote sensing for image classification or radar backscatter image identification. So we only use the one that been developed in satellite remote sensing or terrestrial remote sensing. And this is an example of the synthetic color image. Okay, the what we call it as a hue saturation intensity. Okay, if you familiar with remote sensing data analysis, then I think you aware of this HSI, which is a measure of synthetic color image from the backscatter map. It is actually to improve the display of subtle large-scale features while retaining the fine detail, the original detail of the image. Okay, it is some sort of like image enhancement of the backscatter data. Okay, originally used in the radar image analysis. Okay, this is an example of the textural property of mean value from the GLCM data. And also, apart from the multi-beam data, we also have the ground truth data, okay, which has been conducted using the underwater drop video. We only use GoPro camera mounted on a specific steel and drop to the areas not too many drops, but we need some information about the sediment types and also the habitat types there. Okay, for example, for this marine park, we only use drop video. You can also, if you have Transat video, or you have some data collected from the diving, you can use also. Okay, because we need to train the machine learning, we need some data. Okay, to train the data, to train the machine learning. That's why we use the underwater drop video. So the drop video will identify what sort of information, how many classes of this habitats in here in this marine park. But you can imagine if you depending on the video only, you need to capture all the data around the marine park. Okay, so this is like a 3 day or 2 or 3 days observation data set. Okay, and also this is some of the sample of the video that we can get from the video, the corals, and also some coral rubbles, okay, dead corals. Okay, okay, this is the method that we propose to use, how we can use the hydrographic data using the acoustic mapping sonar system, and also the ground truth we can get from the drop videos. Okay, this is the flowchart of the process. Okay, so from the acoustic data, we have the bathymetry, the backscatter, and the bathymetry we derive the derivative or secondary information from the derivative. Okay, slope, aspect, verigosity, curvature, and so on. And from the backscatter, from the backscatter derivative, from the backscatter we derive the backscatter derivative, and also we combine all these layer and variables. We use this as input for classification, and we also use the ground truth. Some of the ground truth will be used to train the machine learning. So the hydrographic data and also the ground truth will be used to train the machine learning, and also we use this machine learning to predict the class where we don't have the direct location or the ground truth. Okay, we use the area that we have the ground truth develop the models or train the machine learning, and we can predict the class at the area where we don't have the underwater drop video. This is where we can minimize the numbers of the ground truth collected by using the remotely sense data set. Okay, so we will use this data input into machine learning and to produce the marine habitat map. Okay, and some of the ground truth will be used at the final stage to assist or to validate the classification map. This is the result from the process. Okay, the process is quite long, but this is the final result of the process. Okay, the final result of the process, where we can get detailed maps of the marine different types of marine habitat. We don't have specific classes or species class, but we tend to produce a general map of the coral area, coral distribution. The red color is the distribution of the coral. The blue one is the coarse sand, and the yellow one is the fine sand. So by having this map, we can know where the coral are mainly distributed. For example, we can know that the coral area is located, much of the coral area are concentrated on the northern part of the island, the marine and the Redam island. So this is where we can use this to facilitate the conservation and management process of the corals at this area. So this is what we're talking. We can assist. We use this information to facilitate or to support the SDG number 14, which is to conserve, to manage and conserve the marine habitat. Different areas might have different types of habitats, such as the soft coral, hard coral, or mainly maybe some sort of algae, invertebrate, and so on. So that's why we need some information of the area from the ground truth. So this is the final map that we can use to assist the marine. In Malaysia, we call it marine park units, so that they can plan for future conservation and management plan. And also by using this machine learning technique, okay, from all the variables, we can also assess, or we can also know which variables are the most important variables that we need to use to produce the classification map. For example, we can know here bathymetry, benthic position index, the slope and the aspect, and also the verigosity, and also the GLCME are some of the important variable that needs to be used to capture, to differentiate between corals and different sediment types. Okay, so this is some of the example of using the ability to use machine learning technique. Okay, as for conclusion, okay, I think I have shown you some of the what we can do with the hydrographic data, the ground truth video data, and also the machine learning. We can use it to produce a more meaningful habitat map. Okay, and I think this is the first time we use this technique to produce marine habitat map for Redam Marine Park in Malaysia, and it has good spatial resolution, and also we can use this technique also to minimize the substantial ground truth that we need to get from the diving or video transect, or the any sort of ground truthing technique. Okay, and with this habitat map, okay, marine managers and also the marine authorities will have sufficient information about the detailed spatial distribution of the coral at Radom Marine Park. Okay, this information is useful for to plan for conservation action. For example, area with large coral area where we can contribute it to SDG number 14, life below water. Okay, and also I would like to acknowledge or to thank the relevant agency and such as the National Hydrography Center, Department of Fisheries, the Marine Park Section, Urban Marine Automation, and many more who help us in producing the marine habitat map for Redam Marine Park. Okay, I think that's it for me. Okay, thank you so much. Back to you, the chairperson. If you have any question. Okay, any question so far? I cannot hear anything. Sorry, can you repeat that again? Yes, yes, loud and clear now. Okay, 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 thank you.
Well, I guess it's more on whether there's any questions, any queries that we can clarify.
Right now? Okay. First one, we have question for Miss Diana from Teguh Widodo.
Mm, is it? I believe the question is more of disruptive technologies. Whether the technology disrupted the whole ecosystems and how it should not be disrupted too much um, to the whole ecologies. I'm not too sure. Is that what it means? Because if it is about disruptive technologies, then
Yeah. Yeah.
yeah, once in a while there will be disruptive technologies that come out. It is the same as the very first time when iPhone was introduced, and it really disrupt. So if the question is whether with the disruptive technologies, it disrupt the whole ecosystem of the economies and all these, it will happen once in a while, like for the introduction of the iPhone in the market. It disrupt the whole market of mobile phone, right? So even Nokia got it unaware. Once it's disrupted, it does impact the whole ecosystem of the industry, right? But as we also know, yeah. So we also know that there is not very much disruptive technologies that are introduced within a very short period of time. So basically, like even for iPhone, we just take iPhone as an example. It is they do an improvement over time as well. They don't do very much disruptive technologies every time. Although like even for the improvement itself, a lot of people are looking forward for it. So it really depends how to make sure that it does not disrupt the whole ecosystems or the industry. So if your technology is more on the improvement to improve certain situations of the needs, then I believe that it will not disrupt the industry ecosystems too much. It will displace some of the technologies that are old eventually, but it will not impact too much if it is an improvement kind of technologies. But of course, if we talk about once we have a very disruptive technologies, like when Uber is introduced into the market, it disrupt the whole taxi market and how people do the servicing uh, of transporting from point A to point B. Uh, but it is a phenomenon that will happen in such a short period of time, and there will be a lot of followers that will do the same, right? So the competition will start again. So I believe it is about balancing. We still need some disruptive technologies once in a while to change the whole market, but we don't get to see it very often, I would say. Yeah, thank you. I hope I answered the questions correctly. Yeah.
It means that the challenge always there. It is depend on us how do we make the balance between the technology and the social friendliness itself. And we actually need the disruptive technology to learn our.
Yes. Yeah. So when disruptive technologies will change our behavior as well, it will impact on how we tackle things like when Uber came in and Grab. I mean, Indonesia is Gojek, right? So people change, right? Like for me, I don't need to buy a car. I can travel quite easily using Gojek or Grab. So it changed the behavior of the society as well. So either way, right? So it's either the needs of the society